A warm good afternoon to all my dear students. Now I shall be covering the two important topics, hashing and Strassen matrix application. The searching is a very important aspect of most of the algorithms that we find in any software for that matter. Now let's look at the the two picks that we have. The first one is of an ATM wherein the people are trying to withdraw their money. Let's see what happens when we try to perform an operation using an ATM. The first thing is you give your account number. So when you give an account number, the backend server has to search for your account number in the huge database that it has. The database there would have not just thousands of records, but rather million number of records. This is a snapshot of an online shopping. So you have searched for this particular apparel. So before you search for this, certainly the backend server would have gone through all the apparels and then picked the one that you have opted for. Even this involves a huge search operation. So these kinds of search operation we find in every aspect of life. It could be for your movie booking, or it could be a travel booking they hear, or anything for that matter they hear. Very often the search operation takes place. This only underlines the importance of the search operation. Let's look at a very simple scenario that each one of us would have undergone is walking into a library. So if the library is not very well organized and you go there and you start literally looking for a book of your choice. And it might so happen that you'll have to literally look every corner but still not having found the book. So that this girl, she is literally frustrated as to where the book that she wishes for is there in the library. Let's look at another scenario wherein this library is very well organized and the librarian, she knows where every book is, that she has a magic function with her that tells her that where each book is located. So this boy will just go to the librarian and he says that he tells the name of the book that he wants, and the librarian will clearly indicate which rack, which particular position should he go. So he just goes there and finds the book, and this person is very happy about this. This is what one would wish to have. Now, having underlined the importance of search operation, let's see what algorithms that we have or we have understood so far. One very simple is a linear search. This can be applied for any kind of data, whether it is sorted or not sorted. And its time complexity to order n, not really a very tolerable one. Other better one, much better one is a binary search, which can be applied only when my data is sorted. The time complexities of log n, which is a significant improvement over the n order of n. But I'm not satisfied. I really would want to have something wherein I just have to, like the person in the previous case, the library, just have to go to the position where my data is stored. So can I aspire for a magic function which can tell me where exactly my data is stored without having to go through the other portion of the database. So if I can get such a magic function, my time complexity will be reduced to of the order 1. This is the best possible that one would ever wish for. And whenever you see this time complexity of the order 1, don't mistake that it's that taking 1 unit of time. Rather, it tells that it is constant unit of time. Irrespective you have 1,000 records, 10,000 records or a million records, you will need constant time to perform the operation. This magic function, we call it to be a hash function. Now let's see what the hash function is. Inside the hash function, we are not worried. It's like a black box. I have a record with a particular key to be stored into. I give this key as the input to the hash function. Hash function performs some mathematical operation over this key, some number crunching operation, multiplication, modulus operation, something there here, and it returns me a value, which I call it to be a hash value. This value is an index into the table where this particular key or the data must be stored into. This is the overall picture of a hashing function. So my data to be stored into, I apply to a hashing function that gives me a value which tells me where the data is to be stored into. Now we will have a more detailed example. I have these objects to be stored, object 1, 2, object 3, object 4. And this is my table where I should be storing my data. And I apply the some hashing function, which I'm not bothered about, that returns me a hash value or a hash code. So these are the hash values that are written by the hashing function for these data. Further, I apply a modulus function that tells me the position in the table where the data must be stored into. Let's go through this object 1, applying the hash function, the hash value is 4, apply this modulus 5 function, then it returns me value 4. What is it for telling me? Please go to the location 4 in the table and store the data. What is the data? Object 1. So object 1 is stored in the table at a location 4. Let's take up another example of object 3 is that. So the hashing returns me a value 68. To that further I apply a modulus function, modulus of 5, that will return me a value 3. What is it telling me? Go to the location 3 in the table and store the data which is object 3. This is how one uses a hashing to store the value into the table and further to retrieve or to search for the desired value. So let's again have a closer look at this. Now the operation that I have is, please insert the record Alice. So this is the record of Alice. The name is Alice and this must be some social security number. I give this to my hash function. The hash function is like a black box. It returns me a value 1. The value 1, it is an index into the table where the record Alice must be stored into, and I do store into. As the next is, I am called to insert the record Bob. So then I give this to the hash function and that returns me this table size -1, which I'm not bothered. The some value, it points to this particular location and this is where I store Bob's record into. Now, as the last two were the case of insertion. Now I am asked to search for Alice record. Get is searching the Alice record. Now I exactly do the same thing that I did when I stored Alice record. I apply the same hashing function. It returns me the same value 1. So then I go to the location 1 and peep into and I do find the Alice record which I was looking for. So just see, look at the beauty. I didn't have to run through the other location. I could walk directly to the location where the Alice record was stored. This is the beauty, the power, the strength of hashing. Now, how do I choose a hash function? So the hash function depends upon the type of the key. Is that a string? The previous case, it was a string Alice, Bob's and so forth, or it could be an integer. So depending on that, can one choose an appropriate hashing function? Now the hashing function, the desirable feature is that it should spread out the keys as much as possible in the entire table, and every corner of the table must be reachable through this hashing function. There are a lot more. We will not get into the details of each of this. Now let's see what could be the possible hash function for an integer. The integer really don't have to do anything. Just use the value as it is. To that you apply the modulus function to tell you where exactly in the table should that data be stored into. My table size is fine. The key is 0. I perform this hash of 0. It will give me a value 0. Hash of 5 this 6. The 6 modulus 5 will return me a value 1. So fairly simple. In case if the keys are strings like the way Alice, Bob and so forth, then one way that I can do is I just should have some integer number. How can I arrive at some integer number? Take the ASCII code of each of these characters, sum it up. That will give you some integer and that can be used to perform this hashing. So 65 is the ASCII code of capital A, and again small letter n there are 2. So it is the ASCII code of small letter is 110. Such are there are 2, so it is 2 into 10, and the small letter A, the ASCII code is 97. Sum it up, that will give you 382. to that, you can apply the modulus function, take you to the location in the table. And it's always preferred or advised that the table size must always be a prime number. Why so? It is to reduce the collision that we will understand in the future slide. Now, before to the methods, let's again take through the same example they here. So it is Alice is in the position 1, the Bob is in position last one. Now I have to insert the record Anna, and I see that the hash returns me a value 1, and the Anna is mapped onto a location where Alice is already stored, so that more than one record being mapped onto a same location, being hashed onto a same location, results in a collision. So I just have to this collision. There are two ways to handle it. That is, one is called an open hashing, the other name is separate chaining, the other one is a closed chaining, and the other name is open addressing or probing. Both of these methods are very simple. We'll understand each one of this. So the first method is separate chaining. The idea is very simple. In case if there are more than one record being mapped onto a same hash value, put all such records into a single bucket. Similarly, so all those records which get mapped onto a hash value 1, put it into a bucket, and so forth. This is a very neat and a simple way of handling the situation. So we'll take to an example there here. This is the scenario wherein Alice is at the position 1 and Bob is at the position table size -1. I have the person, the Anna coming in there here. When I apply the hashing function, tells me that go to the location 1. It's already been occupied. No, then what I do is that I just add Anna to this particular record. So all these persons who have been mapped onto 1, I shall maintain in the bucket, or I shall maintain it as a linked list. Very simple method. So but then the downside is that I should do extra coding of assigning the new list nodes, and this code would certainly be a more taxing one, or otherwise the method is very simple. Now the other way to deal with collision is the closed hashing, or the also known as probing. This is also very simple. So all it tells me that whenever you have a collision, don't worry. Now put the item or the element in the next available empty cell. So we will go through an example. So my table is empty. Now should I insert 40? I apply a hashing function. The hashing function is just modulus 11. It gives me 7. I go to 7 and I find that it is empty. Happy day here. I put my number 40. Next, I'm called to insert number 18. I apply hashing function. The hashing tells me that go to 7. I go to 7 and I see that it's already been occupied by 40. No worry. I go to the next location. I find that to be an empty one. So I put my number 18. Now, the next is the number 29 to be inserted. I apply the hashing. Tells me that it is 7. And then I go to 7 and I say it's already been occupied. So go to the next location, even that is occupied. So then I go to the next location, the index 9, it is empty. So I dump the number 29. Now I try to insert the number 9. The hashing tells me it is 9. Go to 9, it's already been occupied. So what I should do, go for the next empty location. The next location is empty. I put the number 9 and P. So next is I am asked to insert the number 21. I apply the hashing function. It gives me the value to my 10 there here, and then I go to 10 and see that it's already been occupied, and I'm done. Now it is perplexed because there are no more location in the table. Not to worry, go back, wrap around, go to the beginning of the table and you see it's an empty there here, put the number 21. So that's the simple approach to handle the question. Now, so far we were trying to insert a number. Now if I'm asked to search for a number, get the number 29. How do I go about? So 29, I apply the same hashing function. It gives me the number 8 location. I go to 8 and then, is this what I'm looking for? I was looking for 29. No, I go to the next location. Yes, 29 I could find, and then I'm done, right? So that the search operation was also fairly very easy here. So this is what probing. So the hashing applications, where all it is used in cryptographic applications, in digital signatures, in blockchain technology, comparing large amounts of data. In all the very recent applications, one needs the hashing. It underlines the importance of hashing. Okay. Now, Now, having understood this, I want each one of you to solve the solved example given in the textbook. Only then you will have a very clear understanding of the theoretical concept that we have understood. After that, please solve the exercise problem, exercise 7.3, the problems 1 and 2. And please note that this is a very important topic, also a simple one. So good chances of getting a question in the examination pertaining to this, and the questions would generally be the problem oriented. Unless you solve that, you would not be in a position to score or answer the question properly. So my sincere advice for you to is do two things. One, solve the example solved problem in the textbook, and then take up the exercise question. So these methods are very simple. Now we'll go to this other topic. It's the matrix multiplication. The matrix multiplication is encoded in several places: linear algebra, digital image processing, visions, and it is neural networks. Very everywhere we see it is matrix multiplication, which tells us how important is this operation here. The naive method, whose time complexity was also cube. So then the straightaway application of a divide and conquer could not get us a better solution. So let's try to do something better in a slightly a different manner. These equations or the formulas that will help you to better prepare for the examination. And the worst case, what might also happen is that you might be given two matrices and being asked to compute the product using this Strassen's matrix method. So one should be very careful in applying this formula, performing this matrix product and getting the result. Okay, fine. Please refer to the document which has already been provided in the canvas day here. So use that to prepare for the examination. Yes, thank you.